one of the co-organizers of this event. So I just wanted to take a minute to thank everybody for coming out tonight. We are doing a lot of effort to try to connect the Toronto-Waterloo corridor with the whole blockchain scene that's going on. We have a whole lot of talent here in Waterloo and a lot of things going on in Toronto, but definitely Waterloo has a very unique ecosystem, and we're really happy to connect and hopefully provide some education, some contacts, and everything so everybody gets a bit more idea of what's going on here and maybe what you can do in the future to get involved or learn a few things. So if you have any questions, we're taking questions throughout the night, throughout the panel. We're going to have a panel a little bit later on, and we are fully encouraging people to ask questions throughout and make it as interactive. We want to keep the content relevant. We have a good mix of people tonight. I think about 40% of the room is business, 40% of the room is tech, and maybe about 10% academic or community or in between. So we're going to try to cover all the bases, maybe without going too far into any one direction, but that being said, if you guys have any questions that we can do to keep things more relevant to what you are interested in here with the actual audience that showed up tonight, just let us know, and we will keep things relevant, answer what you need.
We're almost set up, so...
I can start singing now. I should also make one more comment tonight, which was that in bringing this event together, we were very selective about who we choose to work with and bring to these events. As many of you probably already know, the majority of the blockchain and cryptocurrency industry is a scam, maybe 99%. So I recommend that you're very careful when going down this road, but in that spirit, we only invited people out that we did a very high amount of due diligence on, and people that we believe are true white knights in the industry that are bringing forth good ethos and have good intentions. So I'm really happy to welcome Nilu because I believe she's not only very intelligent and very skilled at what she does, but she's really good at digesting that information and making it accessible to a common people. So without further ado, here's Nilu.
Okay, so in today's, I guess, not really lesson, but presentation, we're just going to talk a little bit about kind of what blockchain is, cutting through the hype a little bit and kind of getting down to the nitty-gritty of what it actually is and what its purpose actually is. And then we're going to dive into a little bit more technical side, looking at an actual smart contract and just seeing like where something like a blockchain would be applicable in like a problem that we maybe have today. So to get started, I want to talk a little bit about who we are and what we do. I'm from a company called BlockGeeks, and at BlockGeeks, we are an education company training engineers and developers to become blockchain engineers. So we have online content. We are an online subscription-based platform, so you can sign up for our platform, watch video content. We do in-person workshops, kind of like, I'm doing a pseudo workshop today, but we do more like hands-on workshops as well. And we have free articles and guides. And one of the things we really offer is that we are connected to a lot of companies that are in this space. So for developers who essentially want to learn about blockchain technology and then find employment in one of the companies that are actually requiring blockchain engineers, we help bridge that gap and we help people go from kind of education to like the job market. And yeah, that's basically what we do. And okay, now that we've talked about that, we can dive into what a blockchain is. So a blockchain is basically, if you guys think about it at a very, very basic level, it's just a peer-to-peer network that has some shared data across multiple computers or entities, right? So if you think about data, or like how we interact with information currently, we're mostly using a client-server model. So a client-server model is basically, like you have something like Facebook or Amazon or Google, and it has one record of all the information, all the data, whether it's about your profiles or it's about a website, search engine, whatever. It stores all the data, and then whenever you want to interact with that data, whether that's for adding new information to it or retrieving information from it, you basically send requests to this centralized kind of entity, and then that they change their record, and then everyone sees the changed results. Whereas in a peer-to-peer network, you're dealing with whoever, like individuals directly. So let's say if Facebook was a peer-to-peer network, instead of me updating my profile picture and then sending that information to Facebook and then everyone else can request it, I would send that information directly to every person's computer that I was interacting with. So every one of my friends, I would send that information directly to their computers. So there's no middleman. And the idea of a peer-to-peer network is actually not super revolutionary. It's been around for a long time. So if you guys think about like torrenting, like BitTorrent, or even Napster kind of, you'll see that peer-to-peer networks where you're sharing data directly with the other people that you're interacting with has been around for a long time. But what's really been blocking kind of peer-to-peer networks from taking off has been this idea of consensus. So when you're thinking about transferring information between many different computers, right? Every single one of them is going to have a different, like you have to maintain the same record across many, many different computers, right? So that means that all the different computers have to agree with each other that there's one, that they have the same version of the data on all of their computers, and that, oh no. There we go. I have to just like hold it up and just, okay. Yeah, so that's essentially where the revolution of a blockchain comes in, is that, so for something like Napster, you don't really care if the other person has the same data on the computer that you do. You're just transferring information. But for example, if you're thinking about like a peer-to-peer bank, you want to make sure that everyone who's in that banking network has the same record of transactions, right? Like for example, what if on my computer it says that you gave me $20, but on your computer it says that I gave you $20. Who's right? If there's no person in the middle to say, you know, Nilu's right or you are right, how do we kind of mitigate that, right? And that's essentially been the kind of problem of why peer-to-peer networks haven't been adopted, and that's basically the problem that Bitcoin solved. So Bitcoin actually, the inventor of Bitcoin, who was actually an anonymous person named Satoshi Nakamoto, what they came up with was a system that allowed multiple entities or multiple nodes in a network to be able to have the same record of the data and achieve consensus without needing an intermediary like a bank or like Amazon or Facebook or anybody in the middle who says this is the true record of transactions. And they created a mechanism that allows everyone to have the same record and to agree with each other without essentially having to trust each other. And that was really revolutionary because it allowed for something called digital cash. So that's essentially what Bitcoin was. Bitcoin was, if you think about what cash is, with cash you don't need anything like a bank to transact. You have the physical money in your hand, and you can transact with someone, and it's very like clearly known that I'm giving this money to you, and I don't need, it's not recorded anywhere, and I don't need anybody else to make that transfer happen. But cash's limitation is that you need to be physically in the same space as somebody else. You need to give them a physical, I guess, currency or like physical money, right? Whereas what we're benefiting with like digital transactions is that we can transact across the world and we can have like fast transactions. And so Bitcoin actually brought that. And that has been really what changed the world, creating this like network where you didn't need to trust each other and you were able to transact with the kind of privacy and security of cash, but also with the efficiency of a digital network. And so basically Bitcoin, as revolutionary as it was, it served a very, very particular purpose. So like I said, it was just physical cash. So the only thing you could ever do with Bitcoin is send and receive money, which is essentially the Bitcoin token. And once that kind of came out, and once people started seeing that Bitcoin worked, so it was kind of like a proof of concept. It came out and people started to see that this actually works, and like people are able to transact without having to trust on a middleman or like a intermediary party. They started to think about, well, there's so many other things we can do that require middlemen, right? There's so many other things that businesses, or like if you think about like governance or in management or even in finance, financial services, there's so many things that right now we're relying on these kind of like middlemen who are sort of like rent seekers in the middle, that we could actually use this like consensus mechanism or this blockchain system to basically codify that information. So that's where Ethereum comes in. So Ethereum basically uses the same consensus protocol and the same kind of peer-to-peer network that Bitcoin does, but it's actually a general purpose computation platform. So whereas with Bitcoin, the only thing you could do was send and receive money, with Ethereum, you can actually like write your own programs using something called smart contracts, and you could do anything that you could do basically with like regular computer programming, but at the same time using this like blockchain network and this like consensus network without having to deal with the complexity yourself, and without having to build that network yourself. You get to take advantage of it, and you get to build your applications on top of it, and that's really really exciting. So the blockchain is basically secured using modern cryptography, hashing, and digital signatures. So it uses digital signatures to kind of sign every transaction, so you know exactly who sends every single transaction. And the modern cryptography and hashing is used in a process called proof of work that basically uses computation power to make the network secure. So that means it essentially makes it more difficult for people to, it makes it more difficult and more expensive for somebody to try to break the network, to try to alter a transaction, or to try to cheat the system in any way. I won't get into the details of proof of work right now, but if you guys want, you can definitely learn more about it in our courses. So what are some implications of blockchain right now? So the biggest thing is that it's censorship resistant, right? So because anyone can join and no one has kind of authority to change anything or to deny anybody from entering it, anyone can join the blockchain, anyone can create, and no one can essentially stop them. And it's guaranteed execution. So because it's running, so if you're writing a program onto the Ethereum blockchain, it's running on thousands of computers at the same time. So once you like deploy a contract, or you execute a transaction, or you call a function, there's no way to stop it. It will execute on all the computers. And that's, again, it goes back to kind of like censorship resistance. You can't stop something once it's been set in motion. And again, it's a trustless environment. So you can do all these kinds of economic transactions that you would need to have like legal or kind of middlemen mitigating them before. You can kind of do them without that kind of system, because you don't need to trust. You don't need to trust each other in this system. That's kind of taken care of mechanically. And so, talking a little bit about what smart contracts are now. The way that we can think about smart contracts, they're basically like, if you guys are familiar with object-oriented programming languages, they're basically like classes. So you basically have a class. Inside that class, there's some data and there's some methods that manipulate that data. And a smart contract will have an address. So on the blockchain, everybody or every entity has an address. So an address could belong to an individual, a person, or a smart contract. And individuals can interact with smart contracts by calling particular functions. Smart contracts can interact with smart contracts by calling particular functions. And they can transfer money to each other as well. So if you think about smart contracts as having addresses, it kind of opens up this whole world where you kind of have machines interacting with machines. So you can kind of build these like bigger systems, or they're actually called decentralized autonomous organizations, or DAOs, where you have essentially a suite of different smart contracts that get triggered and call each other at different functions, and you have a whole system that's running without any kind of human intervention. So that's kind of super cool as well. And ultimately, smart contracts, we write them in kind of high-level languages that are easy for us to understand and kind of code in, but they essentially get compiled down to something called EVM bytecode, which is Ethereum virtual machine bytecode. So every machine that's on the Ethereum blockchain is running an Ethereum virtual machine on it. So, and that's because we want all the code from the smart contract that we write to be run in exactly the same way. So all the code will essentially get compiled down to bytecode and then run on the EVM. So we know that the contract or like the function is executed in exactly the same way across all the machines. So there's no discrepancy in the data or the way that the functions get executed. And yeah, so some languages that are available right now to code in for smart contract creation: LLL, Serpent, Solidity, Bamboo, Viper, Mutant. These are some of the languages. Solidity is by far the most popular and most well-adopted language so far. It has the biggest community behind it and the most kind of like tooling and support for developers to get started with. Viper is another popular one. A lot of like Ethereum core developers are interested in Viper and like building with Viper because it's kind of similar to Python. Solidity is very similar to JavaScript, so that's why it kind of has the biggest adoption because like every developer knows JavaScript. Cool, so like I want to just go over some examples for smart contracts. Like I mentioned, a decentralized autonomous organization would be an example. Initial coin offerings, like obviously, I'm sure most of you guys have heard of those. It's just like crowdfunding through a smart contract without having to rely on a legal entity. Escrow for purchase transactions. We're going to go through an escrow contract today so you guys can get a more clear sense of how a blockchain would be useful here. Multi-signature wallets is another example of smart contracts. And some current limitations. So as exciting as it is to kind of be in this blockchain world and like see the potentials that it has, it's still very, very early in the game. So there's still a lot of problems, and we're still a long way from being at a point where this is there's mass adoption or like people are using this all the time. So one of the biggest hurdles to it is that you have to pay to use it. So for every transaction that you're posting to the blockchain, you as the person posting the transaction has to pay. So imagine if you were on Facebook and you had to pay every time you liked a photo or pay every time you uploaded a picture. A lot of people wouldn't use that, right? And it would be too expensive for a company to say, I'm gonna like pay for every single one of my users. Like you'd basically be losing money every time you want to get users to use your platform. And also there's other challenges, basically scaling challenges. So I don't know how many of you guys heard about CryptoKitties a couple of months back, but CryptoKitties was basically a kind of game that was created on the blockchain where you could get these like crypto cats and you could breed them and you could sell them and trade them. And a lot of people started using it. And what ended up happening is that the entire kind of Ethereum network basically shut down because all these people there was like so many people that were using the network, and it just couldn't handle it. It wasn't at the scale where it could handle it. So that's still a problem, but it's a technical problem that is being worked on. And also, it's still really early. There's still a lot of people that don't know about it, and the user interface for a lot of these platforms is not quite there yet. And also at this point, you still need to pass data to it from the real world. So you're not really getting the complete sort of like censorship resistant, like no one tampering with idea of the blockchain at this point because you do still need to pass data to it from the real world. But all these problems are fixable problems, and hopefully in the next 5 to 10 years, they will be resolved. Cool, so now that I've kind of given you an overall understanding of what blockchain is, I'm going to give you guys a quick coding demo. So, sorry, let me just move this over here. Cool, so this is what I'm on, the website that I'm on right now is called Remix. And Remix is an integrated development environment, and it's just a website, so remix.ethereum.org. And it's a really easy place, you don't have to download anything, but if you just want to practice writing smart contracts or deploying smart contracts, you can do so on this platform, and it's really easy. So you basically have this thing on the side here where you can add your files or see your files. You have this tab over here where you can essentially deploy your smart contracts, and then you can have some like sample accounts where you can transact with them and like call transactions on it just to test your smart contract to see if it's working. And then you have this thing at the bottom. Let me see if I can get it. It's like really, okay. It's this thing right here. And this is kind of like a console. So you can basically, once you interact with your smart contract and you have some transactions in there, it'll give you a log of the transactions. And then if you want to write some like JavaScript in here to interact with your contract, you can do that here as well. But depending on how much time we have, we might do some of that, but I just want to walk through what this contract is. So I'm going to give you guys a little overview of what the contract is first. This is an escrow burn contract. So if you guys think about an escrow, it's usually like two people trying to have a transaction. Let's say someone wants to buy a house or something, right? And then each of the parties doesn't really trust the other one, right? Because on the one hand, the person says, well, if I give you the house, I want to make sure that that you have the money first. So give me the money and then I'll give you the house. And then the other side is saying, well, why don't you give me the house first and then I'll give you the money? Because I don't know if I give you the money, you'll give me the house. So usually you have somebody like a middleman or someone who says, I'm going to hold the money, but I'm not going to give it to them. And then once you give me the house, once they give you the house, then I'll release the money to them. So both parties are kind of satisfied. And so here, instead of relying on some sort of middle character, like an arbiter or someone to mitigate this transaction, we're just going to do it using a smart contract. So in the smart contract, so this is actually a Berg contract. So the way that it works is that for the transaction, for the contract to essentially initiate, we have a buyer and a seller, and they both have to deposit some amount of money into the contract before it initiates. So both of them are putting down a stake. So the buyer is saying, let's say, you know, I want to buy something for $500. I'm going to put $100 down, even though I'm a buyer, and the seller is going to put $100 down too. So they essentially put some stake in, and then the contract holds that. And then the transaction processes, right? So like, let's say the buyer also puts in the money into the contract for the item that they're buying. And if the transaction is successfully delivered, then the buyer can essentially, give a confirmation to the smart contract to say that the contract was, or that the item was delivered properly. And then when the item is delivered properly, then both of their stakes are released to them. So in this way, so this is kind of a small example of crypto economics and of how you can code incentives into a technology to be able to make sure that people that don't trust each other can transact. So basically in this way, one of the problems with the contract originally was, well, if I pay my money and I don't get the item, what happens? Or if I get the item but no one pays me, what happens? This way, both the buyer and seller have placed something in, so they don't have an incentive to cheat anymore. There's more profitable for each one of them to essentially complete the transaction, and that's why the transaction will complete. And so we can walk through a little bit more in detail if you guys want about the kind of structure of how the smart contract works. So to start a smart contract, this is written in Solidity, by the way. You just define your contract. We're going to call this one escrow. And then, so we have, like I mentioned, we have some variables. So we have an address for the buyer, for the seller, and then we have a Boolean. So Boolean means true or false value. Boolean for whether the buyer is in or the seller is in. And that just means that they put in their initial stake for this contract to initiate. And then we have a unit price. And the price is the price of the good as well as the price of the stake. So they have to pay this much in to be able to commit, to be able to initiate the contract, basically. And so the first function in every smart contract is a constructor function. And the constructor function gets run when you deploy your contract to the blockchain. So this essentially sets the initial state of the contract. So it says, so you basically say constructor, and then you tell it what initial information you want. So you want to tell it who the buyer is, who the seller is, and what your price is. And so the constructor essentially creates the contract, sets these initial variables, and then creates all the functions, the functionality for you to be able to call the functions of the contract. So once the contract is constructed, essentially, you can call any of the contracts in here, and it will essentially do something. So, and like I said, we have our first contract called initiate contract, where it's payable, so that means that it will receive Ether. And it basically checks to see that the buyer is in, the buyer pays some Ether to it, the seller pays some Ether to it, and then it says if they are in, it changes the state of the contract to awaiting payment. So like up here we have different states, and the different states basically say where in this transaction process the contract is. And you can check that at any point, and the state will essentially tell you what the next transaction that needs to happen is. And then, so once the contract is essentially initiated, you can just check the state of the contract and it will say awaiting payment. And then once the buyer can confirm the payment and say, so the buyer will confirm the payment by actually paying Ether again into the contract. So once they pay the Ether, now the state of the contract is moved to awaiting delivery. And once it's in awaiting delivery, the only transaction that can happen is for the buyer to confirm the delivery. So the buyer basically waits the item is delivered to them, and then once the item is delivered, the buyer will get their initial stake back that they put in, and the seller will get their stake as well as the price of the actual good. So they'll get both money, with both funds basically, and then the state of the contract becomes complete. And until this confirmed delivery doesn't happen, neither the seller nor the buyer will get their money. And so that's their incentive to make sure that they're going to work together and resolve any kind of disputes that come up. So yeah, that's basically it as far as demonstrating this smart contract. I believe somebody from QuantStamp.
What if the buyer, the confirm function, what if the buyer gets the item and does not run the confirm function?
So yeah, that's exactly what I was explaining, right? So because both of them, so let's say like you and I enter this contract, right? So let's say I'm the seller and you're the buyer, and you want to sell me, or whatever, like I want to sell you maybe a shirt, right? So for the contract to initiate, let's say the contract has a price of $100, right? So for us to be able to begin our transaction, you need to put in $100 and I need to put in $100, right? So now we both put in $100, then you pay me whatever, $200, whatever the price of the code is, right? And then once you pay me that money, it goes into this confirmed delivery state, and I deliver you the code, right?
Maybe the state should be like always bigger than the amount of the purchase price of the item, right? The state should be always be higher than that item.
Well, it doesn't really matter if it's higher or lower because you're also adding the price of the item as well, right? Well, I guess because the buyer's paying for.
If I buy a house and I have to stake $100, I'm not going to run that function. I'm just going to get the house and leave my.
But you're also paying for the house before it. You're paying for it here, so you wouldn't go to this confirmed delivery state. Like I wouldn't give you the house until you've done this part. Yeah. So you would be paying the price of the house plus a stake. Yeah. Okay. So like I was saying, it probably takes a little bit of time to wrap your head around it, but like this is the kinds of transactions where you're not relying on a middleman to mitigate these transactions. So the last thing I wanted to leave you guys off with is one of the biggest concerns with blockchain smart contracts, especially because once you deploy them to the blockchain, they can't be changed or updated, is security. So I'm sure you guys have heard of issues where some money was locked in a smart contract and then someone hacked it and a bunch of money was lost and couldn't be retrieved. So because of this, one of the most important, I guess, entities in the blockchain space are security auditing platforms or companies that will actually look at your smart contracts before you deploy them and make sure that there are no bugs or no potential vulnerabilities where someone could basically hack you or steal your money or do kind of crazy things like that. And so we have someone here from QuantStamp who is going to basically run through this contract and show us what some potential vulnerabilities are and how to kind of fight against them. And that guy is Martin, so coming up, Martin.